What's up, everybody? Today we are having a legendary software craftsman, Mr. Robert Martin. You also know him as Uncle Bob. He has more than 50 years of experience in software development. He is one of my great authors in this field. He is co-author of Agile Manifesto. He's a writer of the series like Clean Code, Clean Architecture, Clean Coder, and as I mentioned, he's one of my favorite author. He is the one behind Solid Principles. He's the pioneer of Solid Principles. Also, we have tons of interesting questions related to Solid Principles today. So I'm having privilege to meet you, Mr. Martin, today. This is my pleasure. I am a bit excited. Sorry about that, having you. So thank you very much for accepting our invitation.
That's my pleasure. Sounds like fun.
Thank you. So my first question, if you are ready, we can start.
Sure,
Ah,
sure.
great. My first question is about single responsibility principle. I know I have watched a lot of videos of you where you explain all this stuff about single responsibility. It is not about responsibility, it is about people. But today I want you to clarify it a bit more because when I ask developers like what is single responsibility principle, they are taking into account that there is responsibility world. Okay, it means every class, every module, every object should have one single responsibility. So, long story short, is single responsibility about single responsibility?
Well, yes, it is, but not from that point of view. So the single responsibility principle says that a software module, whether that's a class or some other kind of module,
Yeah.
should have one reason to change.
Mhm.
There should be one thing, one person really, but one thing that causes it to change or that asks for changes.
Mhm.
And that is a responsibility to a user. It's usually users that
Mhm.
want changes. So if you have a system, that system is probably going to have many different users and many different kinds of users. You might
Mhm.
have system administrators, you might have clerical people,
Yeah.
you might have maintenance people. There might be a whole bunch of different kinds of users. Each of those different kinds of users will ask for certain kinds of
Okay.
changes. And the system has a responsibility to those users. The single responsibility principle says that any given module should be
Okay.
responsible to only one kind of user. And the reason for that is that we don't want the changes that are requested by one kind of user to break the behavior that other users expect. So we want
Um,
to separate those behaviors by the kinds of users that the system has. That's
okay.
what that principle means.
That's cool explanation. Thank you very much. So, some of developers think that, for example, if I have, let's talk in terms of modern programming like C Sharp, Java, it doesn't matter. If you have a database class with create, read, update, delete functionality, it means it is all related to database. So in all context, these have a single responsibility. So it is not about technical perspective. Yeah. In one context, this database class may have really single responsibility, but in other context, it is just breaking single responsibility, isn't it?
Well, if you have user interface code
Okay.
intermixed with database code, then you are clearly violating the single responsibility principle because there's one group of people who are very interested in the GUI or very
Okay.
interested in the user interface. There's a completely different group of people who are interested in the schema of the database. And
Okay.
so those are two different responsibilities and two different kinds of changes that you don't want coming into the same module. I mean, it would be awful, right? If somebody made a minor change to the UI and that broke the schema of the database.
Okay.
And,
Yeah.
and of course, that kind of thing does happen from time to time.
Yeah, exactly, exactly. So the main point of my question is when you design something, some internal class object, it is responsibility may vary depending on the context or not. I'm just talking from the backside. Let's say I'm just a backend engineer. I'm developing API. So I have, as I mentioned, the class with 4 methods. In one context, it may have single responsibility because the owner is one single group of people or one single person. But in another context, the same class may have multiple owners, which break single responsibility. Yeah, that's good. So,
Yes. So,
I'm not,
in situations like that, you want to ask yourself, where are the changes going to come from? Can you draw a circle around the users and the interested parties where the changes are going to come from, and then isolate those changes as best you can?
yeah, yeah,
Is it always perfect? No, it's not always perfect. Sometimes you will have, you know, mixed
definitely.
responsibilities.
Mixed
It's
version.
always engineering, right? There's always a trade-off. But you do the best job you can. Try and keep
Yeah,
the stream of changes separate.
exactly, exactly. That's really cool explanation. Thank you very much. So another interesting question I got from my audience was, if you had to remove one principle from Solid, which one would you remove and why?
Wow. Well, I'd probably move the interface segregation principle because that would change the acronym to SOLD.
So, only for this reason? So, uh, you know what? I have around 10 years of experience as mentoring, teaching, programming stuff. So, as far as I see, most of developers struggling with exactly Liskov substitution principle than with other principles. Yeah. So, question is, let's look at from the technical perspective. Is overriding the method completely breaks Liskov substitution principle? We have hierarchy, inheritance, and child class completely overrides the parent class.
Okay. So you have a
Yeah,
derived
so
class that completely
yeah,
overrides the base. All right.
completely overrides things. So does it mean that it is breaking the contract and it is breaking the Liskov substitution principle?
Well, it depends on if it breaks the contract. Does it break the contract? And it's
Yeah,
perfectly possible to have a derived class that completely overrides the base class, but does not break the contract of the base
yes.
class.
Mm-hmm.
Right? That's
So
possible.
yeah, so it depends if it breaks the contract. For example, in my parent class, I have some exceptions throwing some validation stuff. So the child completely overrides or adds additional responsibilities, additional validation stuff. So it is going to break the Liskov substitution principle. Yeah. Because we talk.
If there is an input you can send to the base class that the derived class will reject, that's a Liskov violation.
Let's go violate.
You should be able to do anything to a derivative that you can do to a base. The derivative can do more, but it can't do less.
Okay.
And it can't require more. It can't add constraints to the inputs.
Mm-hmm.
Right? So there's an old saying, right? Don't ask for more, don't deliver less. The derived class can't ask for more and it can't deliver less than the base class.
Mm-hmm. Yeah. So it is about precondition and postcondition. Yeah.
Yeah, absolutely. Yeah. It's
Yeah.
all about the contract. with the users of the base.
Indeed.
So there's three elements there, right? There's the user, there's the base, and there's the derivatives.
Yeah.
And it's the contract between the user and the base that has to be maintained by the derivatives.
Oh, that's cool. My next question is actually from my side. Are you happy with modern object-oriented programming tools? Are they really object-oriented? I mean, we are using C#. I am .NET engineer. I don't think that it is completely object-oriented. And same is applicable for Java. There may be other programming modern object-oriented called programming language. So as a software craftsman, as a source of truth, what do you think about it?
Okay, well, we can talk about the languages if you'd like. I mean, Java's a fine language. C Sharp is a fine language. They're old now. I mean, they were conceived in the mid-90s, and both of them have gone through the process of peaking and then coming down the other side. And this happens to languages. They reach a kind of peak where they're maximally useful. And then the architects of the language keep on throwing junk into them, and that weakens the language and weakens the language. And both of those languages have passed that point. So, I think adding lambdas to Java was a big mistake. I have a feeling that even adding some of the generic stuff to Java was a big mistake. It's just got too weird and too complicated. Same thing happened to C Sharp. Same thing happened to C++. That did not happen to C. C remains a nice, pretty little language with almost none of that junk thrown into it. Unfortunately, it's not a very useful language nowadays. At least in my domains.
Yeah, it is also.
So, am I happy with the object-oriented languages? I'm not unhappy. I kind of think that Java and C Sharp are diminishing. Ruby, I thought, did a nice job for a while, but it gets a little complicated. It's got too many widgets in it. Python's a nice language. It's an okay language. I haven't spent a lot of time with Swift, a little bit, not much. I haven't spent a lot of time with Kotlin. I haven't spent a lot of time with Dart. Go's not bad. I've spent a little time with Go. I've done a little Go. It's a bad language. It's pleasant. But my favorite language of all right now is Clojure. I really like Clojure. It's a very pleasant language. Got good object-oriented capabilities, good functional capabilities. So that'll be my language probably for the next decade.
Yeah. Oh.
Yeah. And by then I'll be 82, and I don't know if I'm going to be programming at 82. Might be. I hope so.
I hope
Might
so.
be weaving baskets. I don't know what I'm going to be doing.
Yeah. Talking about this programming language, what do you think? Which programming language nowadays describes best attributes of object-oriented programming? So you say that, okay, this language is 95% object-oriented, around 90, but not completely object-oriented programming.
I'm not sure percentages actually work. So you can write perfectly good object-oriented programs in Java or C Sharp or Ruby or Python. I don't think you can rate them as how object-oriented they are.
Yeah, it depends from.
I would rate them differently. I would rate them in how expressive they are, how easy to use they are, how capable they are, how big a library they have underneath supporting them. And all of those languages are very capable languages. Java, C Sharp, Python, Ruby, Go, all very capable languages. The cleanest in that batch is probably Go. Probably Go.
Oh,
So it's a relatively simple language, although they keep on, but it's a relatively simple language at this point. Again, my favorite is Clojure. It's a really simple language. I'm much happier with that.
How about Smalltalk?
Well, if Smalltalk were a viable language, And I don't mean viable technically, I mean viable socially. I'm
Okay.
not quite sure why Smalltalk has diminished so much. But what a beautiful language it is. It's a gorgeous language, very simple, very expressive, very easy. It had, and maybe I'll continue to use it in the present tense. It has a different theory of source code, right? We don't create source code files necessarily, right? We create the image, and the image is kind of a database that you load code into. And that's such a foreign concept for most programmers that I think they can't get into it for some reason.
Mm.
I don't know if that's the reason why Smalltalk isn't popular. It really ought to be. It's a very, very nice language.
Mhm. I know many people actually in software development, I think that there was a golden age of software development. You, Martin Fowler, Ken Beck, Bertram Meyer, Rebecca Wersbrook. So what we are missing from this golden age, what was not possible to deliver to modern developers? You worked a lot on this, but we misunderstood this.
So there's two factors here.
Okay.
The first one is that the period of time you're talking about is from like the 1960s to the year 2000.
Okay.
And that was the era of Moore's law. The
Mm.
machines themselves were becoming more powerful at an astounding rate.
Okay.
And all of us were riding that wave. It was immense, a wave of technology, and we were all riding it. And every time we turned around, our machines became more capable. And so we
Okay.
were able to do more interesting things. In the early days, no one would have thought about doing objects. It's too expensive, too many pointers, too much indirection. And indirection took time. In those days, an indirect access would be 2 microseconds. That was too much time. Couldn't afford that. And then go forward about 5 years. All of a sudden, indirections are really cheap, but we don't have a lot of memory. And memory is still really expensive. So you can't
Yeah.
have garbage collection, for God's sake, because you can't have all that junk hanging around in memory. You've got to keep memory tight. And then you go forward 5 years, and it's like we've got all the memory in the world. When we can have garbage collection all we want. And now, an indirect reference is a nanosecond. So we rode that wave, and that wave of capability was allowed us to grow the capability of software.
Mhm.
That stopped.
Uh,
That stopped
yeah.
in 2003, right? More clock rates have not improved since 2003. They've been stuck at a couple of gigahertz. What is it now? What is my machine? 1.6 or 1.8 gigahertz or 3 gigahertz? I can't remember. But
Okay.
the clock rates have just plain stopped. Machines are not getting more powerful. And for a little while, we thought that machines would continue to get more powerful by adding more cores. So we
Okay.
got dual core, we got the quad core, but that stopped. Oh, and they did that hyper threading thing that makes you pretend like you've got 8 cores, but it's really just 4. There's not 8 cores in there, right? And that stopped too. And
Mm.
all of that technological progress has stalled. Now
Oh,
there's little bits of it left.
okay.
Memory gets a little bit better. We're taking
Exactly.
all the disks, we're getting rid of the disks and replacing them with solid state. And okay, that's all getting slightly better. But that crazy exponential growth is gone. And
Mhm.
so the challenge now is, how do we live on the technology plateau? We
Okay.
all climbed the technology mountain. You guys have to live on the technology plateau. And how do you do that? One of the attributes of the mountain is that we were just inventing things left and right. There were ideas were just pouring out. We had the agile ideas, we had OO ideas, we had functional ideas, we had design patterns, had
Um,
solid principles. All these ideas were just spinning and pouring out because the technology enabled us so much.
yeah.
But now it's time to prune that tree.
Oh.
how many languages do we actually need? Why do we have so many?
Yes. This is a
Right?
good question.
Maybe you guys are going to have to prune the tree of languages down to two,
Yeah.
one. I don't know. But I think that will have to be done. There will have to be a very serious look at the number of languages and realize that we don't need that many. We don't want that many. It's detrimental to have that many. And we're probably going to have to reduce that down to a very small subset. The other problem, that was just one problem.
Okay.
The other problem is also an exponential growth problem, but it's the number of programmers in the world.
Oh,
For the last 50 years, the number of programmers in the world, in this last 70 years, really, the number of programmers in the world has doubled every 5 years. And that crazy exponential growth means that half the programmers in the world have less than 5 years experience. And so there's very little opportunity for young programmers to learn from older people because there are not a lot of us older people around, right?
yes,
There's
definitely.
a lot of young ones. There's not a lot of old ones. And that's not because the old ones are gone, because most of us are still here. It's just there weren't very many of us. There aren't a lot of people who have 50 years experience in the field. Right? There's a
Yeah,
few, and you
few.
named them.
Exactly few.
Martin Fowler, Rebecca Werfsbrock, me, Grady Boots. There's a bunch
Yeah.
of us, but you
Canvas.
can count us on, a few
Only fingers.
hands.
Yeah. Unfortunately.
And there's
Unfortunately.
hundreds of millions of programmers. So that's the other problem. It's just a vast lack of experience problem.
Okay. That's really great explanation. Thank you. But
Yeah,
the
sure.
programmers you are talking, are they really programmers or just coders?
Oh, I'm not sure I want to make that distinction. Programmers, coders, developers.
Yeah.
I think that's it's all the same definition. If you
Yeah.
want to have a a way to categorize programmers, I would just do that by years of experience and say,
Mhm.
okay, if you've got 5 years experience, you're a junior. You got 10 years experience, you're intermediate. You got 15 years experience, you're probably senior level.
Don't mention it
Generally
like
speaking.
this. Actually, nowadays in the world, if you have, for example, in our country, if you have 3 years of experience, you are senior. 1 year is junior. Between 2 and 3, you are middle engineer. Yeah.
Yeah. Well, that's just a symptom of the crazy exponential growth.
Mm,
That's because there just aren't enough programmers to manage, to be senior. But it does take a good 5 years to cross the boundary from junior to mid. Takes
mm.
another 5 years to cross from mid to senior. I mean, you would not want airline pilots to use the 1, 2, and 3 year model,
Definitely.
or doctors,
Yeah,
or lawyers,
yeah,
right?
exactly. I'm completely agree with you. So you guys did a lot of cool stuff, like you, Ken Beck, Grady Booch, Martin Fowler, all this golden age people. But why things getting harder than easier? For example, um, 20 years ago or 15 years ago, it was enough to use one language with one database. But now you should be a polyglot engineer with CI/CD pipeline stuff, DevOps skills, good database skills. Why things turn like that?
Okay, so I mean, if I go back in time 40 years,
Okay.
so I'm a young programmer. What did I have to do? I had to deal with the database. I had to deal with the data pipeline. I had to deal with the DevOps. I had to deal with it all because programmers in those days didn't specialize. If you needed a
Yeah.
graphical user interface, okay, well, programmers would do that. We didn't have designers. We didn't have front end people. We
One
didn't have
single
middleware
code.
people. We didn't have back end people. We all did everything. And so it hasn't actually gotten harder. It's just that people are specializing And they don't want to leave their specialties. And by the way, that's just poison, right?
Yeah.
If you're going to do a specialty, get out of that specialty. Learn another one and another one and another one. That's part of why it takes 5 and 10 and
Mm,
15 years to move into mid-level and senior level kinds of positions. A good senior programmer just wipes all that stuff away and says, I don't care. I can do GUI. I can do database. I can do middleware. I can deal with all this nonsense. You want me to do
yeah.
DevOps? I'll do DevOps. I don't care. It's all programming. It's all software. That's a
No.
senior level guy. That's why it seems hard. It's not
Mm.
hard. It's just what it takes to get stuff
Oh,
done.
uh-huh. Yeah. Great explanation. My questions turn from solid to different perspectives. So let's continue with solid principles.
Hey,
So one interesting question here is solid principles have been a cornerstone for many developers. In what ways do you think these principles have impacted development world? And what is one of the biggest misconceptions about them?
oh boy. Okay, so how do the solid principles impact the development world? I hope that those principles just give programmers a few things to think about.
Yeah.
When you're writing code, when you're looking at code, when you're architecting systems, those principles can allow you to step back and look with a jaded eye and say, well, do I really have this system structured so that when changes come in, I'm not changing the whole thing?
Yeah, exactly.
Have I been able to focus on one thing? Is this derived class here going to cause me any trouble? Have I broken a contract somewhere? It's a way to just kind of sit back and reflect. Um, you might think of them as a kind of checklist to go through every once in a while. You look at the structure of your system and you just walk through the list right now. Have I isolated the responsibilities well? Have I
Yeah,
maintained openness and
guideline.
closeness? All of that stuff, right? Simple, just a way to walk through in your mind and think through what the possible problems are and how you can restructure them. That's what I hope the impact has been. What is the biggest misconception?
Yeah.
Okay, the biggest misconception is that they are upfront tools. You must
Oh,
design according to the solid principles.
yeah.
Every month, all the code you write, the instant you write it, will be solid.
Stop.
That's just not the way it works.
Yeah.
Usually, you write a lot of bad code, and then you have to look back at it. Then you step back, and that's when you start asking yourself the questions. Okay, is this subclass really right? Have I done this one okay? It's a checklist after the fact. Doesn't mean that you can't think about it up front a little bit. You can.
Okay.
We all do, but it's much more valuable on the back end, right? And almost everything we do to make code better happens on the back end, not on the front end.
Yeah,
Right?
definitely.
Doesn't mean you shouldn't think about design up front. Doesn't mean you shouldn't think about architecture up front. But the real improvements happen on the back end when you reconsider what you have done. I like to think of the writing of systems
Yeah.
the same way I would write a book.
Mm-hmm.
When I write a book, I write a lot of crap. And then I read it and I prune it and I change it and I restructure it and I shuffle it. And then I read it again and prune it and shuffle it. I'm making several passes over it to make it better and better long before the publisher ever sees it. And
But
code
yeah,
is the same way, right? It's the same way. And every teacher has taught this to every third grader in the world, right?
yeah.
Write it the rough draft, then do a second draft, then do a third draft, then it'll be ready.
Yeah, but unfortunately, in most companies, we don't have enough time that you had. You have time to read, let's say, refactor, but we don't have this time. How about in this case, we have really short deadlines. Okay, let's complete it. So, is it about principles or delivering stuff?
So, the fear of time is the thing that slows us down.
Mhm.
And it slows us down because we make the point you just made. We don't have time to do it right.
Exactly.
If you don't do it right, you're going to slow down. And everybody knows that. Everybody
Definitely.
knows when they bring up code on their screen and that code's a mess, they're going to be slowed down. Why is the code a mess? Because they didn't have time to clean it.
Yes, exactly.
So there's this real problem in logic with that kind of reasoning. Of course you have the time, because
Mm.
the only way to go fast is to keep everything nice and clean. Every sushi chef knows this. Every surgeon knows this.
Definitely.
Every home contractor, every carpenter, every artist knows this. The only way you are going to reach the deadline in time is to do a really good job and clean everything really well. Otherwise, you're going to dig yourself a hole you can't get out of.
Ah,
Right?
mm,
So you do have the time.
yeah, yeah, definitely. But it is sometimes, not sometimes, but mostly hard to explain the manager class people that
You don't
we,
explain it to them at all. You
but I
never
think,
explain these things to managers. It's none of their business, right?
mm,
The way we write code is none of their business. Our practices for writing code is our business, right? They
definitely.
don't need to know that we wrote it and then we made a few passes over it. They don't
Mhm.
care about that. Why would they care about that? They don't need to know that we're writing unit tests. They don't need to know that. That's our
Definitely.
business.
Yeah,
You don't ask them whether or not you can wash your hands after going to the bathroom. That's not their business.
yeah, definitely.
And the
Def
way we write our code is not their business. They want it done on time. They want it done according to a schedule. And the way to get it done according to a schedule is to do the best damn job you can. Keep that stuff as clean as you possibly can. That's your only shot.
yeah,
So you never
definitely.
tell them. You never tell them. And you never ask. You never ask, is it okay if I write tests? You never do that. You never say, oh, is it okay if I refactor? Never, ever do that.
Mm.
Never put the risk on them because they're not going to take it. The risk belongs with us.
Yeah, but sometimes it is about balancing between the time and good code. I don't have enough time. I need to do things fast, but how I can deliver in a given short amount of time a good code. I will definitely have some mess code fragments in my code, and every sprint, every session, it is going more and more, more and more, and somewhere it's going to turn to big ball of mud. So, so yeah.
Yes. Well,
Uh,
I mean, kind of answered your own question. Yes, that is what will happen.
yeah.
Right? So you do have the time because if you don't take the time, the entire project will slow down and slow down and slow down forever. Thing about bad code is that it doesn't just slow you down. It slows everyone down who ever touches it over and over and over again. The cost of bad code is felt again and again and again and again.
Yeah.
The cost to clean code is felt once.
Great explanation. The other question from audience is, yeah, actually I got several questions, but they are approximately same. The impact of AI to software development field. They ask that what Robert Martin thinking about AI. We have this cool tool. I'm just typing, okay, write this algorithm for me. I have this requirement. I'm just copy and pasting it to the chat GPT copilot, and they are generating all this cool stuff. So does it mean that I don't need to now too much instead of deeping dive to all these solid principles, design principles? Maybe it is better to learn ChatGPT prompts, right? So maybe a few basic programming skills with good skills of AI will give me a chance to work in a good company for a good company. So what do you think about the impact of AI? The long story short is the question.
Yeah, AI is a power tool. It's a
Mhm.
very interesting tool. It's a stupid tool, and no one should ever think that it's intelligent, but it's a
Mhm.
tool, and it's got a lot of very good uses. However,
Well, yeah, the
you
interesting
better know
parts
your
that's here.
principles really well, because the code that thing is going to spew at you is going to require you to look at it very carefully and judge it very carefully. I
Mhm.
use it all the time. I use AIs all the time nowadays. I hooked up Copilot to my IDEs. When I type into my
Okay.
IDE, it offers me code.
Yeah,
It sits
exactly.
there. It throws code at me, and I look
Progression
at
of
the code
Copilot.
and I think, "Mm, yeah, no," and I delete that code. Every once in a while, it'll
Uh-huh.
put something up there, and I think, oh, well, that was really helpful. Thanks a bunch, and I might make a little change to it. But most of the time, it's like, no, get that off. That's stupid.
Ah,
Don't
maybe
do that.
you are not using
So
progression.
I don't expect to, I don't expect that to ever change. I expect that it will offer me things and I will reject a lot of them. Now, when I'm initially writing code, I don't reject as much.
Okay.
But when I am refactoring code, when I am cleaning code, I reject almost everything
Mhm.
because it's not very good at that. It's pretty good at anticipating the next 5 lines of code. It's pretty good at that. If I start to write a module, it'll go, oh, and it'll fill it out for me. And I'll look at it and think, yeah, that might work. Change a little bit. But if
Okay.
I'm in there refactoring, if I'm saying, well, now I think I ought to change this around a little bit, it's hopeless. It has no idea. And it
Uh,
shouldn't have idea because that's where you're really using programming judgment.
okay.
When you're first writing code, there's not a lot of judgment there, right? Just I got to do this, I got to do that, I
Yeah.
got to do this,
Yeah.
and it can kind of go, okay, yeah, well, I can repeat that for you if you'd like. But then when you're in there refactoring, you're using a lot of judgment.
Mhm.
So the thing about AIs is that, yes, they can be very advantageous, but in order to use them well, you have to have your judgment tuned up really high.
Mm.
You better know those principles well. You better know the good refactorings. You better know object-oriented principles and functional principles. You better be really good at it.
Okay.
And for that reason, I would suggest that beginning programmers should not use the AI at all. It's
Yeah.
kind of like a very beginning carpenter should probably not use a power saw right away. Right away. Let them use a handsaw for a while, get the feel of the wood, understand how saws work, and
Yeah.
then maybe when they're mid-level, you can start letting them use power tools.
Mhm. So in terms of programming, the AI, the ChatGPT Copilot, is like a junior engineer doing something for you, and as a senior, you're doing refactoring over it, something like
I think
this.
that's a reasonable analogy, but I wouldn't give the AIs that much credit. They're not like a
Mm.
junior engineer. They're more like a well-trained dog.
Ah,
You
your
know,
assistant,
they
yeah.
can go fetch things.
Mhm. But
They're not really great at thinking through problems, but they can fetch. And what they're really doing is they're fetching solutions that other people have written, right? Because
Mhm.
they've got this massive large language model and they're searching through a huge amount of code. And okay, yeah, they can put together solutions that other people have written and they can do a little bit of reasoning to fit it into your project. But
Okay.
that's more like a well-trained dog. Right?
Ah,
And
okay.
and they're really not even that intelligent, but I gotta come up with some analogy.
So nowadays, they are propagating this AI, saying that in the next 5, 10 years, they will replace your job. Let's go to Web3, learn Web3. the cryptography, other stuff. So do you think that AI is one of the biggest scam nowadays, which people are propagating, or the things they are saying are completely okay? I'm agree with it 100%.
I don't think anybody's going to lose their job. This has been a fear since the very beginning of programming. At the very, very start, when the first machines, 1940s, right? When the programmers were literally punching individual holes in paper tape, one at a time.
Yeah.
And Grace Hopper said, there might be a better way. And she came up with a really primitive compiler. And all the programmers went, oh my God, we're all going to lose our jobs now. And the opposite happened. The more powerful our tools became, the more programmers we needed to use those powerful tools. And that pattern has not changed. Every time there's a better tool, we need even more programmers to use these better tools. I assume that's the same thing that's going to happen with AI. I don't think anybody's going to lose their job. And certainly the AIs are not going to be writing all the systems. It will still be us, we programmers who put these systems together. We might be doing a lot more prompting, but even that prompting is still going to be programming.
Yeah. But nowadays, I'm hearing a lot of information news about the people losing their job. They say that people already started to lose their job because of AI. For example, we have a company called A, and in the beginning, they were requiring 10 engineers, but now with 2 engineers, with ChatGPT, they can handle all this stuff. So 9 of them are out of stuff. So the process already started, or we are talking about completely different stuff.
Oh no, I think we're talking about the same thing. I don't hold out a lot of hope for the decision that A just made.
Yeah. That's a good answer. How about the no code stuff?
That's been around for like a zillion years.
Oh.
Everybody's always trying to figure out a way to get rid of the programmers. If only we could get rid of programmers,
Yeah.
life would be so much better. And so we always come up with these tools. Been happening for 50 years. Let's come up with a tool. So all we have to do is push a few little buttons, fill out a
Yeah.
few little forms, and everything will work. And then, of course, you want to do something that you have to hire a programmer for.
Yeah. It is about looking for a silver
Every
bullet. Yeah.
single time. Yeah, so the no code stuff is fine if you can make use of it, that's great, but it will not get rid of the programmers because you always want to do something that the programmers are necessary to have. One of the real problems with the no code stuff is that it's very hard to write tests. They expect that you're going to fill out all the forms and click all the right buttons and drag all the right things, and then your whole system will work, and you haven't figured out a way to test it. And testing it with live data is not a great idea. So then you need programmers to come in there and figure out a way to test it. And then the programmers have to take the whole thing apart and put it all back together in some kind of testable way. And some of those no code tools make that almost impossible.
Yeah. Great explanation. The other interesting question here is, how do you balance technical depth with maintaining clean code in long-running projects where business requirements often change? So the balance between all this stuff.
So the balance is the way you think about technical debt. Technical debt is not a mess. A mess is entirely different, right? We don't want to make messes. So I like to think of it in terms of a home mortgage versus a teenager with a credit card. Teenager with a credit card is going to make a mess, usually, right? because,
Yeah.
oh, that's free money.
Yeah,
You,
definitely.
you find out that it's actually not very free a little later, right? So that's what making a mess is. A mortgage is something that you plan out.
Mhm.
You look at it really carefully. You're looking 20 years into the future. You're looking at your income. You're balancing all that and balancing the benefit of living in the home against paying all that interest over 20 years, and you make the decision rationally to go into debt. Now,
Okay.
in software, that is equivalent to choosing suboptimal solutions,
Mhm.
not messes, suboptimal solutions to the problems that customers may have. So you may put in fewer features.
Okay.
You may put in less glittery UI. You know, we can do this. We can do this sooner if we put up a really basic UI. You know, but if you want all this really fancy drag and drop stuff, well, that's probably going to take a longer
Mm.
time.
Exactly.
That's a technical debt. That's true technical debt.
Okay.
When you choose a simpler, less I'm hunting for the word, less global solution.
Mhm.
You know, you're going to make your customers disappointed because they're going to get less. But
Mhm.
what they get is going to work and it's going to be high quality. That's technical debt. And then you can pay back that debt by gradually increasing the capability of the systems to make the customers happier and happier slowly,
Yeah.
as opposed to trying to get the final system done at once.
Yeah, but how about, for example, I'm a software developer. I know that the writing in this way is not good, but we don't have enough time. So I'm adding mess to our project and creating a technical debt
Yeah?
in the future to refactor it. Will I refactor it?
No,
No.
you never will. You never will, because the pressure never stops. The next feature is going to come, and the next feature is going to come, and the next feature is going to come, and you will never go
Mm,
back and fix that mess. It's
that
not a
mess.
technical debt. That's
Yeah,
just a
yes.
mess. You will never go back and fix that mess. And at some point, the mess is going to be so bad. It will get to the point where future progress becomes impossible.
Okay.
And then all the development team says, the only hope for this system is that we have to redesign it from scratch.
Mm.
And that's when you know you have completely failed.
Exactly. Exactly. Oh, another interesting question. The real reason for discovering clean architecture. There was onion architecture, hexagonal architecture. Why you thought that, okay, we need this clean architecture? What was wrong with already existing architectures to think on a new architecture? Or it is not
Oh,
new, it is just a refactored version of the previous ones. So yeah, your thoughts about it.
yeah. There's nothing wrong with those architectures. Hexagonal architecture is a lovely piece of work.
Yeah, I love
Um,
Alistair.
the stuff by Jim Copleen and Trygve Rinskog, great stuff. All these architectures are nicely phrased. They're all roughly similar.
Hmm.
The clean architecture was just another restatement. Um, my goal was to state it in a way that Java programmers and C# programmers could very quickly identify with.
Hmm.
Uh, and that was just my restatement. I thought Alistair did a great job, but I thought there was a way to come at it from a different angle that would appeal to a different group of people.
Hmm.
Nothing more than that.
Okay, so is it okay to use onion architecture and clean architecture and hexagonal architecture as synonyms? Because in most cases, I rely that people using the as a synonyms. So
I think that's exactly right. They are pretty much synonyms. There are minor differences, but the differences are small, right?
Hmm.
If you built a system using ports and adapters, and then later on somebody else came along and looked at it, they might have a really hard time deciding whether or not you were using ports and adapters or hexagonal architecture or clean architecture or DCI, because they're all going to be roughly the same.
Hmm. That's great. Yeah, that's great. So about clean architecture, we are implementing clean architecture using the layers like domain layer, application layer, infrastructure layer, and API layer from the backend side. So I realized that the domain layer is pretty much similar, brings with it the pretty much similar ideas from the domain-driven design.
Yeah.
So yeah, so what are the relations between the domain-driven design? How much domain-driven design we should know to not to implement direct domain-driven design stuff, but follow the clean architecture? Yeah, that's question.
So Eric Evans wrote that book 25 years ago. Now,
Exactly.
it's one of those books that came out at the end of your golden era.
Yeah, yeah.
Uh, and it was a watershed book. It was a all we all read it back then, and we all thought, well, okay, finally somebody said this in a way that we can
Mhm.
all agree. And yeah, I did a pretty good job. Like
Mhm.
I liked the way everything came out. So I think everybody should read that book, or at least the first half of that book.
Okay.
The second half, maybe not, but the first half was pretty good.
Okay.
Everybody should be familiar with the ideas of domain-driven design. Everyone should understand why we want a ubiquitous language and why we want to separate things in just that way.
Yeah.
And then apply it to all of this architecture stuff. You can apply that to the
Okay.
clean architecture. You can apply it to ports and adapters or any of these other architectures. It's just a way to think about and subdivide the problem in a way that we can assemble a reasonable architecture.
Okay. Okay. That's great. So, do you think that from the domain-driven design perspective, let's dive a bit to the elements of the domain-driven design. So, designing domain layer in clean architecture uses the tactical patterns from domain-driven design, like designing entities, value objects, the domain events, aggregates, all this stuff. So, uh, I realized that in many projects, even GitHub, even in a corporate projects, when they divide domain layer as a separate layer, they are using just entity framework entities. With Geren and Ceteren, there is no logic, and they are calling these objects domain objects. What do you think about it? Are they really
Um,
domain objects?
it's well, okay. This actually goes back in time a fair bit. There was, for a very long time, there was an idea that the domain model
Yeah.
was the database model. They were the same.
Hmm.
And you'd come up with an entity relationship diagram that would describe the schema of the database, and that was your domain model. And the problem with that viewpoint is that it has no behavior. Whereas the goal of the business is to implement behaviors. Now, you
Definitely.
might need data structures to do that, but we want to know what the behaviors are. So, in the clean architecture, in ports and adapters, in all of these architectures, the business objects contain behavior. They might use data
Hmm.
objects, they might use containers of data, they might use data structures, but the business objects represent behavior. And
Oh,
that's the major difference there. Now, a good domain-driven design contains behavior. I mean, Eric Evans made that very, very clear, right? Behavior is what we're after.
yes.
Yes, you need to be able to subdivide the data. You've got to be able to have a good data model, But the data model is not the behavior model. The data model is not the business model. The data model is not the domain.
Mhm.
The data model is just a part of that. And
Exactly.
it's taken a very long time for the industry to understand that well, and most of the industry still does not.
So nowadays, many of the, let's say, leaders in software development propagating the domain-driven design. And do you think that it is the era of domain-driven design because we shifted from the simple applications to the complex applications? Computers are growing, business requirements, creating a complex application, getting more and more popular. That's why shifting from database-driven applications to domain-driven applications is a natural process, or it is also another, not, let's not to say scam, but it is another mm, overestimated stuff.
Well, I don't know. My guess there would be that it's overestimated. But the
Mhm.
only reason I say that is that we overestimate everything at first. Right. We really overestimated service-oriented architecture,
Mhm.
25 years ago.
Microservices
That was going to change
nowadays.
everything. And then yeah, we had to change that to microservices. And then that was really great. But well, it turns out that, they're nice, but not
Yeah,
great.
they
And we
are.
overestimated object orientation. Objects were going to dominate the world. Okay, they're useful. It's nice to have that. So my guess is that whatever the latest fad is, it's probably overhyped and overestimated. AI, same thing with AI.
Mhm. Yeah.
Probably pretty overestimated. So my guess is that if there's some new fad that's, domain driven, it's probably overestimated. Not that it's bad, just that, our expectation is that we're all still looking for the silver bullet,
Well, yeah,
you know,
terrible.
the one thing that's going to fix software.
Fit for
Sorry,
everything. Yeah,
sorry.
for all type of solutions. Yeah. Yeah, that's why we always will need software engineers who thinks from the perspective of the context. Yeah, context is king. Context matters. Yeah, that's cool. So, yeah, Trier plus, yeah, we already asked about this question. Yes, about the clean code principles. Let's go for it. So, can you explain how the concept of clean code has evolved since you first introduced it to the world? Do you
Oh,
need to write another clean code book, maybe the second edition for it, and say that, guys, it was back then 2008, now things changed, what? It is the second version and have a fun.
I am in the midst of writing the second edition right now. It's
Oh,
sitting on my screen.
that's great when we can see the published version. Are you
Yeah, that should be out next year.
Oh, that's cool. That's cool. I would be the
Yeah.
first buyer, definitely. Are you going to change a lot? Maybe you can provide some sneak peeks for us. Are you going
There are
to
several
change a
things
lot?
that I'm changing. Or I should say adding. I'm
Okay.
adding a lot of things to it because there were many things that I did not put in that book that I probably should have.
Hmm.
So I'm doing that. I'm also explaining things better because the book, when it came out, although it was very successful, um, there have been a number of confusions.
Hmm.
And so I thought, okay, I can probably explain things a little bit better.
Yeah.
Um, I'm also um, restating and how do I put this? It's not exactly a
Rephrasing?
complete rewrite, but I'd say about 80% of it is
Okay.
rewritten or shuffled or somehow re-edited. I've really done a lot of work on it to try and to better explain the initial message. The initial message hasn't changed at all.
Oh.
But the way the explanations are done, the examples that I've put in are done. It was all done in Java, the original one. This one is Java. It's C, it's C, it's C++, it's Python, it's Ruby, it's Go. I've got all kinds of different languages in there to try to make the point that clean code is not about one language. It's about language in general. It's about coding in general. So I've done a lot of work on this. I'm getting close to the first rough draft.
Oh, even. Oh, that's really cool news. That's really cool news. So, should we wait a lot of interesting stuff? I hope so. I really hope so. Yeah. Should we wait?
I'm sorry.
Yeah. Should we wait?
The question?
Yeah. Can you hear me? Well?
Yeah, I hear you.
Yeah. Should we wait a lot of interesting stuff, or it is just one, two new things and that's all in general?
Well, the basic message is still the same. We want our things, we want nice short functions. We want things to be nicely named. We want to be able to subdivide things well. So that hasn't changed much at all. Most of it is in the presentation. The presentation has been modernized to use newer languages. Some of the principles have been shifted a little bit. But if you were to compare the first edition to the second edition and then boil it down to a message, the message would be the same.
Okay, that's great to hear. And yeah, we already talked about AI stuff. So clean architecture emphasizes the separation of concerns between different layers of an application. How can developers strike the right balance between separation and the complexity that sometimes comes with it?
So that's actually a very good question. And the answer to that is that the balance has to be struck continuously. There is no way to strike it once. As a system starts out, it starts out relatively simple. And the number of layers you're going to need in that simple system might be one. Right? You may not need any real architecture. You may not need any real subdivision to get the first release out of some simple system.
Okay.
Then by the time you get to the next release, things are getting a little complicated, and you realize that to manage that, you're going to have to separate it a little bit. And you can apply the rules of clean architecture to separate things, get the dependencies moving in the right direction, make sure that low-level things depend on high-level things and high-level things don't depend on low-level things. All those nice little rules you can get in place. Maybe you wind up with 2 layers. And then as the system gets more and more complicated, you think, oh my God, I've got to separate this out again. So it's a continuous thing. You're always doing it. You're always splitting things apart. The architecture grows. It is not something you plan out vastly in advance. You allow it to grow with the system. Doesn't mean you're not thinking it through. Just means that you allow it to grow gradually with the system as the system gets more and more complicated.
Slowly, yeah. Yeah. Great.
That's the only way to do a balance.
Yes.
You have to balance it every day.
So directly applying without knowing more about business and trying to apply all these principles, clean architecture from the first class. What do you think about it? So I'm a software developer. Let me say one example. I'm a software developer, let's say middle engineer. They are talking about something. I even don't know the whole domain, but I learned clean architecture. I know it is good. I know some principles, and I will do my best to separate things, to write cool things, And I'm actually doing pre-measured generalization from the starting. Yes. So what are the side effects of applying all this stuff, doing pre-measured generalization from the first sprint, let's say, without
Oh, well,
knowing
I mean,
business well? It is
and you
all,
don't understand the business.
yeah.
Uh, yeah, yeah. So the side effect of that, or the cost of that, is that the separations you will create won't separate the right things. So at some point, you're going to realize that, and then you'll have to undo those separations and then redo the right separations. So, first of all, there's a relatively high cost in separation itself. Separation is not cost free, right? We do it because it gives us efficiencies. But in the early days, if you can get away without separating things, pretty
Complexity.
good. Eventually, you're going to have to do it. So, premature separation is going to cost you something, and you will never get that money back because you'll have to end it, you'll have
Yeah.
to undo it, and then redo it correctly. That's
Yeah.
really the whole point behind Yagni. You know, you aren't going to need
Yeah.
it.
Gonna need it. Yeah,
Um,
definitely.
right. And
So,
eventually you probably are going to need it, but right now you're not going to need it. So it might be a good idea not to put too much generalization in too early.
yeah.
There is a moment when you realize, and it takes a little bit of experience to do this, but there's a moment when you realize I better not go any further without separating things. And that's why you want people with 5 and 10 and 15 years experience in there, because those are the guys who are going to be looking at this going, uh-oh, time to start separating, guys, because if we go further, we're going to make a terrible mess.
Mm-hmm. Yeah, that's great. That's great explanation. So, do you think that all of the stuff I am talking about software developers, doesn't matter if it's front end, back end, anyway, do we need to understand business well? How much should we understand business? Because as a software developer, mostly what we're doing, let me tell you a real example. You have assigned a user story. You're just trying to figure it out, the exact user story you're related. You think that you are the different country, you are isolated from this project, and your job is just finish this user story, and that's all. There will not be side effects. So I don't need to understand whole business. So I have this user story. Okay, I will have some questions, and that's all. So what about this? Business. Business is scary part of software developers because we love just coding stuff. Don't tell me about business. Just give me, and I'm ready to write something. Yeah.
Yeah. The one of the first jobs I ever had, I was a young man in my 20s, and we were writing software for a system that measured the electronic characteristics of telephone lines. Our
Okay.
customer was the telephone company.
Mm-hmm.
And the CEO of my company said every programmer has to get into a truck with a telephone repairman and spend a day with the telephone repairman so that you understand what the hell these guys are going through.
Oh, yeah, that seems really good practice in this context.
Programmers must know the business domain. They have to know the business domain. They don't have to be experts in it, but they have to understand what their customers are facing. They have to know what the customer experience is and why they are writing the system they are writing. You know, why are we making this system? What
Yeah.
problem are we really solving? How are we helping these people? And
Mm.
that is fundamental to any kind of successful project. Yeah, we're not going to sit there and just throw requirements at programmers. That's dumb.
Yeah. Exactly, exactly. So, what about introvert engineers? Because nowadays, as far as I see, the most developers are introvert. They don't talk too much. If you don't talk too much, it means you are not asking a lot. If you are not asking a lot, it means you are not interested or not able to learn about the business. So do you think that these soft skills should be must have in the arsenal of software engineer? Now, when all these HRs check your background, they should also check that you are not introvert. Introverted testing. Yeah.
So we have to be careful with our terms because introversion is not necessarily a detriment. I mean, it's good to be an introvert if you're a programmer because you are going to be spending most of your time at the
Yes.
keyboard, heads down, focused like a laser. And
This
that
is
takes a certain introverted personality.
mm-hmm.
On the other hand, every programmer has to learn how to break out of that shell, if only for a few minutes,
Yeah, it is
and
all.
deal with people.
Mm-hmm.
And so my son runs a software company,
Yeah, I know.
and the way he onboards people is he runs them through a 3-month period. It varies; it's 3 to 6 months, but he runs them through a 3-month period of technical training and technical tests.
Oh.
But also, everybody has to be able to stand up and give a talk on a technical topic. Everybody has to be able to write a blog. Everybody
Mm-hmm.
has to be able to interact with other people. So they have to pass them around, and they talk to all of the other mentors in that group, and they interact with each other.
Mm-hmm.
That's a critical skill for becoming one of the developers in this company. And that's something I think everybody ought to exercise. If you're a programmer, you should be writing things for other people, not code. You should
Mm-hmm.
be writing documents. You should be
Yeah.
writing stories. You should be
Explaining.
writing treatises. You should be able to stand up in front of a group of developers and explain things. And you have to order your words properly. You have to structure your speech properly. You have to get your thoughts in order, and you have to put yourself in their mindset. Right? And that's a very interesting skill to have. And
Mm-hmm.
if you can do that, well, then you have all the skills you need to deal with customers, to deal with managers, to deal with your fellow programmers,
Mm-hmm.
and then go back into your introvert shell and code for 5 hours. And
Thank you.
all of that can happen for you.
Mm-hmm.
They are skills that you can develop.
Mm-hmm. Really cool explanation. And the time for microservices, clean architecture and microservices. With the rise of microservices, do you think the principles of clean architecture needs to be adapted to microservices? How do
No,
you see them applied in highly distributed systems? I wrecked my question. So, is microservices is another scam nowadays? Are they
I don't want to
too
call it a
much?
scam.
Uh-huh.
It's not a scam. It's a technique. It's a good technique. It's been around for a very long time. I mean, okay, we gave it a new name, but the idea is not a new idea. Microservices are not architectural in nature. They're a deployment strategy.
Mhm.
They are a way to deploy a system in a distributed way. But the separations that you make when you build microservices are no different from the separations you make when you're doing a well-structured monolith. They
Mhm.
aren't different, right? You're still separating things according to the exact same rules. The only difference is that you're taking some of those pieces and you're putting them in different processors, and you're trying to communicate over a really thin wire with a low data rate,
Mhm.
comparative to the data rate of a monolith. Inside a monolith, you've got a hell of a data rate.
Yeah.
Once you're squirting stuff over the wire, you've got a data rate that's 100,000 times slower. Right. So
Mhm.
then there are a number of disadvantages to that. So you want to be very careful with microservices. They are not the architecture of the future. There
Mhm.
are uses for them, perfectly good uses, mostly having to do with scalability, a little bit with security, but they are not an architectural goal. You
Uh-huh.
don't want to have microservices. They are a cost, not a benefit, generally speaking.
Mhm.
So no, there's nothing about clean architecture that has to be adapted to microservices.
Okay. Okay. So for the separate services in terms of microservices, we are completely okay to use the same clean architecture, just looking at a separate application and applying it, yeah?
Yes,
So, but
yes.
how about the microservice? Yeah, microservice is not an architecture, it is principle, yeah, or it is a software development style we are applying.
It's a deployment strategy, right?
Deployment.
Microservices are just a way to deploy the system in a slightly different way.
Mhm.
But it's not a principle of any kind. When one microservice talks to another, all that's really going on there is that one is calling a function in another, passing arguments and calling a function, and
Yeah,
then the function returns a value. Right? That's all that's really going on there. If you were to put them together into a monolith, they would just call a function.
exactly. Yeah, we are
With the
doing
arguments. So all you're doing is taking that function call and you're trying to spit it over a wire.
loosely
There's no
coupled.
principle involved with that,
Mhm.
right? That's just physically moving them apart, and then you have to deal with the slow data rate. You don't
Yeah.
want chatty stuff going on between microservices.
Okay, so when we divide this stuff, we are using asynchronous microservices. We are applying loosely coupling, so everything
Yep.
is good. Yeah, sender doesn't know about receiver, receiver doesn't know about sender, all this plus stuff. And
You can do all that in a monolith.
yeah,
All
definitely.
those benefits you can get inside a monolith, right?
Exactly. Exactly. So, okay, so the let's switch maybe to test-driven development.
Oh my, okay.
Yeah. So in terms of test-driven development, what exactly do you think about test-driven development? Because in a classical manner, we are writing tests at the end, the unit tests. But in terms of test-driven development, we are thinking first the communication, all this proper object creation stuff. Test-driven development maybe help us to create better design. Yeah. And we are applying most cases the test first, but it may need more skills than writing in a classical manner. So, what exactly do you think about the test-driven development? Should we apply it everywhere, or we have some golden rules, the golden context to apply test-driven development?
Test-driven development is a discipline.
Hmm?
It is a very intense discipline in writing individual lines of code. It the discipline forces you into a very intense feedback cycle, which is 20 seconds long, 30 seconds long. You literally write a little test. Then you write a little code that makes the test pass. Then you write another little bit of a test, another little bit of code, and you keep it at that very intense level.
Yeah.
That's helpful. It's helpful for a number of reasons. Number one, you get a test suite that tests just about everything, which
Mhm.
is very, very beneficial. Number two, you have to think through the code on the production side from the point of view of a user, the test being a user, which means that you are making the production code more approachable by another user. You're also
Okay.
making the production code testable, right? You're forced to make it testable because you are writing the test first.
Yeah.
All these things are lovely little advantages. That's all. beautiful advantages. If we have a test suite that we trust,
Okay.
then we can clean the code. You bring code up on your screen, it's a mess. And if you don't have a test suite, you're not going to touch it. You're going to go, oh my God, that's a mess. But if I touch it, I'll break it. If I break it, it becomes mine forever. Somebody else can clean this damn code. It's not going to be me.
Yeah.
If, on the other hand, you have a test suite that you trust, then you'll bring that code up on your screen. It'll be terrible, awful, messy code. And all of a sudden you're going, well, I could make this little change and run the test. Oh, I haven't broken anything. Okay, well, I'll make this little change, run the test. Yeah, I haven't broken anything. Good. And then you can check the code in cleaner than you checked it out. Every time. Every time you can check the code in cleaner than you checked it out. And everybody else can too. And so the system gets cleaner and cleaner and cleaner with time. That is the reason that we adopt that discipline. Can you use other disciplines to achieve that goal? The answer to that is yes. There are several other disciplines that achieve the exact same goal, right?
Okay.
You can use Kent Beck's, he's got this lovely little discipline called test and commit or revert. And that's where you write a little script. And the little script sits there and it watches all your source files. And then you write a little you write a little code.
Okay.
But you don't save the file. Can't save the file yet. You write a little test. You don't save the file yet, right? Because as soon as you save those files, the script kicks in, it runs your tests. If the tests pass, it checks everything in. If the tests fail, it does a git reset hard. and you lose it all.
Yeah.
Right. So that's a very interesting one. It forces you into the same very rapid cycle, really intense cycle, much more tension, right? When you're doing test-driven development, it's kind of relaxed.
Relaxed, yeah.
But with TCR, it's like, oh, great, if I save this, I might lose it all. So there's an interesting kind of tension involved. I have another friend who uses a different discipline, which doesn't have a name, but it's a perfectly valid discipline. What he will do is he will write a limited number of lines of code. And that limit might be 10 or 15 or 20, something like that. And then he will write tests that cover that code. Now, that's a much looser style than test-driven development. Test-driven development is right in there. Every 20 seconds, you're in there. And for him, it's like every 10 minutes.
Oh.
But it works. It works for him. And he produces a suite of tests that he can use to clean the code. So there are a number of disciplines like this, and they are disciplines that will suit various people's personalities. I like test-driven development. That works for me very well. If I had a team of developers, I would have them all doing test-driven development because I want the whole team using the same discipline. Right? So, okay, you'd have to adapt. If you're coming on my team, you're going to have to adapt. If you like one of these other styles, sorry, you're going to have to adapt. But it wouldn't bother me if there were another team that was using a different discipline, as long as it had the ability to create a comprehensive test suite that you can use to clean the code, and as long as it was a relatively intense cycle. I don't want the cycle to be hours long. Seconds, okay. A couple of minutes, maybe 10 minutes, okay. Not an hour, not 2 hours, not 10 hours. I don't want that cycle to go on that long. I won't trust your tests if the cycle goes on that long.
Okay. That's great explanation. So, yeah, and let me ask a different question. What do you think about the place of unit testing in the software development life cycle? In many projects, I realized that there is even a single line of code about unit testing. They are not writing unit tests. They have QA guys. They will test everything manually using all these tools. So some companies started even writing unit tests after 3-4 years. So what do you think about the bypassing the testing stuff from the life cycle?
Well, I think it's suicide. I think it's a really good way to have a project take a very long time to deliver, always dissatisfy your customers, and in the end fail horribly, or maybe if you're lucky, succeed marginally.
Yeah.
But I don't think it's a good way to move forward.
Uh,
We have learned over the years that the best way to make rapid progress and keep a software system pretty clean is to have a good suite of tests uh, that you can run at a moment's notice and run with minimal cost.
mhm.
So yeah, I'm not advocating anybody get back into the mode of not writing tests. Now, most people are still maintaining systems that were written without tests,
Ah,
and they know the problem with that. They experience the heartache.
mhm. But what about the side effects of unit testing from the design perspective? When you have unit test, you should design your class that separates things. It forces you to create additional interface, abstract class. But in case of removing unit test from here, my design will be a little bit simple with not so much interfaces and classes. How about
Yeah,
this?
that's certainly true. Certainly true. The ability to test your code means that your code has to be testable, and making your code testable incurs a certain cost.
Yeah.
Absolutely true. You will add more abstractions, you will have more generalities, you will have more interfaces, more inheritance. All of that is perfectly true, but it pays itself back like a million fold. So, I mean, if you, the ability to run a suite of tests in a minute and know that you haven't broken anything is worth untold pounds of gold. I mean, and that's something that has to be experienced to understand. When you've got 100,000 lines of code out there and you have to reach into that code and make a change, the ability to run those tests and see those tests pass and trust them is absolutely invaluable.
No, that's good to know. And in terms of unit tests, what do you think about the dependency injection? We are using all this stuff. We have a class with 15 injected interfaces, 20 injected interfaces, and it is growing and growing. So what's your point of using the dependency injection? Are we overestimating it? It creates a loosely coupled stuff. So let's register in program CS in a central way, and let's just use dependency injection everywhere. So from the
Yeah,
clean code perspective, let's explain this.
I'm not a big fan of doing that. I like dependency injection. I think it's a fine tool.
Okay.
I don't want thousands of things injected. I don't want hundreds of things injected.
Mhm.
And I don't want anything injected into the core of my system. The core of
Okay.
my system I want to protect. I don't want any funny little at signs in there, any funny little attribute things. I don't want some framework to be poking around inside the core of my system and injecting things. So anything that gets into the core of my system, I will put there explicitly. But I
Yeah.
don't mind injecting things out at the periphery.
Okay.
I will inject things into main. I will inject things into the configuration stuff around the outside. And the kinds of things I inject would be things like factories and strategies that I will then pass inwards into the core of the system. And the core of the system will happily use those factories and strategies without having them being injected. That's the way I like to manage that.
Mhm.
I don't have a problem with dependency injectors. I just don't want to overuse them. I think it's
Yeah.
a power tool that you use with a certain amount of caution.
That's good. And using too much interfaces also breaks encapsulation. Do you think that? Because in this case, the main class, the composer, will lose its encapsulated logic because you are providing everything outside, and this class acts just a mediator that helps to these interfaces to communicate with each other. So every class should encapsulate some information, and in this case, when you provide all the stuff from outside, it is losing its value from the encapsulation perspective also, maybe, yeah?
I'm not sure that I could say that. It might be. It seems to me that you could continue to design things in a way that maintains encapsulation.
Okay.
But anytime you overuse a tool, especially a tool that is dealing with low-level details, which is what dependency injectors do, you're at risk of dependency contamination. So I don't know if I follow along exactly with what you said there, but
Definitely.
there is caution when you're injecting dependencies. Don't inject into the middle. Inject into the outside.
Wow.
That gives you some flexibility, and then you pass the injected things inwards.
Ah, that's great. So we have more questions, but as far as I realize, we are out of time. So yeah, thank you very much, Mr.
Oh,
Martin.
you're very welcome.
Yeah, all these questions. Time just flies. I just realized that we are out of time. It was super excited and super interesting discussion with you. And I'm always asking my important guests to promise to have a second session. In your case, when you have a second edition of the clean architecture, maybe after reading all this stuff, we can have a second session exactly to focus the concrete topic. We just talked a lot at different topics. So maybe it would be better for us to have a separate session in the next few months after publishing your book.
Yeah, anytime you'd like.
I'm so happy to have you today. Thank you very much, Mr. Martin.
Sure.
So yeah, that was really cool. As I mentioned, we have a lot of questions, but we are out of time. So thank you very much for spending time to explaining all this stuff.
Sure.
Yeah. Thank you very much. Have a nice day.
Okay, you too.
Yeah.
Bye-bye.
Thank you. Bye. Bye.